everyone, welcome to Saimedha Koti Hyderabad. ఈ వీడియోలో ట్రాన్స్ఫార్మర్లోని క్లాస్ నెంబర్ 7 గురించి డిస్కస్ చేస్తాను. క్లాస్ నెంబర్ 7 ఈజ్ వోల్టేజ్ రెగ్యులేషన్ ఆఫ్ ట్రాన్స్ఫార్మర్. ఇన్ దిస్ టాపిక్ I would like to discuss short notes and concept through questions. And this course is useful for Andhra Pradesh State Electricity Board AEE exam, Telangana genco, transco, discoms AE exams. So let's start from the short notes, and after that we'll discuss some practice question based on the voltage regulation of transformer. And this short notes is also called the short notes from voltage regulation of the transformer, or sometimes it is also called key points from voltage regulation of the transformer, or observations from voltage regulation of the transformer, or summary points from voltage regulation of transformer, or possible questions from voltage regulation of transformers. So whatever you call, so these are short points, short notes, key points, observations and possible questions from voltage regulation of the transformer. And one of the observation, so that is ideally what is the voltage regulation of the transformer, and practically what is the voltage regulation of order of the voltage regulation. And first one of the observation is ideally percentage voltage regulation of transformer, voltage regulation of transformer is equal to 0%. Ideally percentage voltage regulation of transformer is equal to 0%, and practically percentage voltage regulation of transformer, practical cases percentage voltage regulation of transformer is equal to, is in the order of 5% to the 10%, 5% to 10%. So it is the order of the voltage regulation practical cases. And how do we calculate voltage regulation of the transformer? And this one is percentage voltage regulation of the transformer, is equal to, so VNL minus V full load divided by, so VNL multiplied by 100. And this formula also we can write percentage voltage regulation of the transformer is equal to voltage regulation of transformer, so equal to, so VNL minus V full load divided by V full load. And no load voltage we can call it as, it is a EMF induced in the secondary winding, minus full load voltage is a V2 divided by the E2 multiplied by 100. And here also this VNL is equal to the EMF induced in the secondary winding, and V full load is full load terminal voltage, and V2 divided by V2 multiplied by 100. So change in the secondary terminal voltage from no load to full load, and it is expressed in the percentage fraction of either no load voltage or full load voltage. So if it is expressed in the percentage fraction of the no load voltage, this regulation we can call it as percentage voltage regulation down of the transformer. Another name of this one is percentage voltage regulation down of the transformer. And this voltage regulation, if voltage regulation of the transformer is expressed in percentage fraction of the full load voltage, then voltage regulation is said to be percentage voltage regulation, the voltage regulation of the transformers. So this type of the question, okay, voltage regulation down and voltage regulation up. మరి ఎగ్జామ్లో ఏది తీసుకోవాలా, వోల్టేజ్ రెగ్యులేషన్ డౌన్ తీసుకోవాలా లేదా వోల్టేజ్ రెగ్యులేషన్ అప్ తీసుకోవాలని డౌట్ వచ్చినప్పుడు, ఒకవేళ మెన్షన్ చేయలేదనుకోండి ఏ వోల్టేజ్ రెగ్యులేషన్ ఫైండ్ అవుట్ చేయాలి అన్నప్పుడు, వీ హ్యావ్ టు బి కన్సిడర్ voltage regulation down only. So unless otherwise specially mentioned, okay, unless otherwise specially mentioned, and ఇక్కడ క్వశ్చన్ ఒకవేళ అడిగింది అనుకోండి, నోట్ పాయింట్ ఇక్కడ రాస్తున్నా, unless otherwise specially mentioned, note, unless otherwise specially mentioned voltage regulation of the transformer, in the sense voltage regulation down only, voltage regulation of transformer in the sense voltage regulation down only. This type of the question, unless otherwise specially mentioned, voltage regulation of the transformer in the terms voltage regulation down only. So this is another question. And one more possibility of the question, that is next fourth possibility of the question, how do we calculate the voltage regulation of the transformer in terms of the percentage resistance and percentage reactance? So percentage voltage regulation of the transformer, this regulation of transformer in terms of, okay, in terms of percentage resistance and percentage reactance. How to calculate percentage in terms of the percentage resistance and percentage reactance? And what is the formula? Percentage voltage regulation at any x of the load, any x of load. So generalized formula, any x of the load, percentage voltage regulation of the transformer is equal to, at any x of the load, x into the percentage r cos theta 2, the plus or minus percentage x sin theta 2. So this is the formula to find out voltage regulation of the transformer at any x of the load. So based on this formula, we can expect a question, percentage voltage regulation of the transformer at any x of the load. So where plus sign is for, so in this case where plus sign for, plus is for plus sign for the lagging power factor, and minus sign is for leading power factor load, that is capacitive load. And what is the meaning of x here? X is nothing but fraction of the load, x is equal to 1 for full load condition, x is equal to 1, okay, for full load, and x is equal to 1/2 for half of the full load condition. This type of the question. ఒకవేళ క్వశ్చన్ ఎలా అడుగుతాడంటే, దీని ఫార్ములా నుంచి ఫైండ్ అవుట్ వోల్టేజ్ రెగ్యులేషన్ ఆఫ్ ద ట్రాన్స్ఫార్మర్ ఎట్ ఫుల్ లోడ్ 0.8 పవర్ ఫ్యాక్టర్ ల్యాగ్. And another possibility of the question, find out the voltage regulation of transformer at half load 0.8 power factor lag, at 3/4 at 0.6 power factor leads. So ఎలా అయినా క్వశ్చన్ అడగవచ్చు. ఇలా కాస్ టీటా అనేది పవర్ ఫ్యాక్టర్, సో పవర్ ఫ్యాక్టర్ నుంచి మనం సైన్ టీటా ఫైండ్ అవుట్ చేయొచ్చు. అది చేసిన తర్వాత ఈ వాల్యూస్ని ఇందులో సబ్స్టిట్యూట్ చేస్తే we will get percentage voltage regulation of the transformers. Okay, and this is a generalized formula to find out the percentage voltage regulation. And next one, zero voltage regulation. What is the condition to get the zero voltage regulation? What is the condition to get maximum voltage regulation? Adige chances untayi. And next question is fifth possibility of the question, zero voltage regulation occurs at leading power factor only. So this one is zero voltage regulation. VR means voltage regulation. Zero voltage regulation of transformer occurs at leading power factor only. So this is also one more possibility of the question. And what is the next one? Maximum voltage regulation of transformer occurs at lagging power factor only, inductive loads, lagging power factor only. So this type of the question. And the next one, how do we, what is the condition to get a zero voltage regulation? So that is condition, condition that to get the zero voltage regulation, zero voltage regulation. So that is what is the condition to get the zero voltage regulation. So it is nothing but tan theta 2 is equal to percentage R divided by percentage X. Tan theta is equal to percentage R by percent, or it is also theta 2 is equal to tan inverse of, so percentage R divided by percentage X of the transformer, percentage resistance of the transformer and percentage reactance of the transformer. This is the condition to get the zero voltage regulation of transformer. Condition to get the zero voltage regulation of the transformer. This type of the question. And next possibility of the question is condition to get, okay, this condition to get maximum voltage regulation of the transformer. Condition to get maximum voltage regulation of the transformer. And what is the condition to get the maximum voltage regulation? Tan theta 2 is equal to percentage X divided by the percentage R. So this is the condition to get the zero voltage, maximum voltage regulation. And this also can be written as theta 2 is equal to tan inverse of percentage X divided by percentage R. So this one is condition to get the maximum voltage regulation and condition to get the zero voltage regulation. And another possibility of the question, what is the power factor at which zero voltage regulation occurs? This type of the question. And how to calculate power factor at which zero voltage regulation occurs. And ninth possibility of the question is the power factor, ninth one, the power factor of the transformer, power factor of transformer at which zero voltage regulation occurs. Zero voltage regulation occurs in the transformer, occurs for all zero voltage regulation occurs. How do we get this one? So we know the condition. So we know that. So we know condition to get zero voltage regulation. So condition is, so that is tan theta 2 is equal to percentage R by percentage the X. So now let us write the triangle, and it is a theta 2. So percentage R divided by the percentage X, opposite side by adjacent side. This hypotenuse will become percentage the Z. From this triangle, therefore cos theta is equal to, cos theta 2 is equal to percentage X by percentage Z. And this is the power factor. So it is nothing but power factor here. So power factor is also we can write X equivalent divided by Z equivalent, like so on. So power factor at which zero voltage regulation occurs. So zero voltage regulation occurs in the transformer. So this type of the question. And similarly, next one. So power factor of the transformer at maximum voltage regulation occurs. So another one, power factor of transformer at maximum voltage regulation occurs. So this is also another possibility of the question. And maximum voltage regulation means, so that is cos theta 2 we will get. So now we can solve this one. Suppose condition, first we can derive this from the condition. We know the condition here, or otherwise we can write directly also. Power factor of transformer at maximum voltage regulation occurs. Cos theta 2 is equal to percentage R divided by percentage Z, and this also you can write R equivalent divided by Z equivalent. So this is a formula to find out. So power factor of the transformer at zero voltage regulation occurs, and power factor of the transformer at maximum voltage regulation occurs. Power factor of the transformer at maximum voltage regulation occurs. Cos theta 2 is equal to percentage R by percentage Z, that is also equal to R equivalent divided by Z equivalent. Another possibility of the question is 11th one. Another possibility of the question, and voltage regulation, percentage voltage regulation of the transformer at unity power factors. So this type of the question, percentage voltage regulation of transformer at unity power factor UPF. UPF is equal to percentage resistance of the transformer. And next one, another possibility of the question is percentage maximum voltage regulation of the transformer. Maximum voltage regulation of transformer. So this value is equal to percentage impedance of transformer. And voltage regulation at unity power factor is percentage R, and maximum voltage regulation at unity power factor is equal to percentage impedance of transformer. And percentage voltage regulation of transformer depends on magnitude of the power factor as well as the nature of the power factors. Percentage voltage regulation of transformer depends on magnitude of power factor, and nature of the power factors, and this type of the question. Voltage regulation of the transformer depends on magnitude of power factor and nature of the power factors. Now let us write voltage regulation curve. So this is the percentage approximation voltage regulation curve. So this is the approximator voltage. So positive voltage regulation, and this one is the negative voltage regulation and positive. And I am assuming here one power factor 0.8 and 0.6 lag, 0.4 lag, 0.2 lag, and it is a 0. So this is lagging power factor side, lagging power factor region, and this is a leading power factor region. So here also 1, if it is a 1 here, so now this origin is a 1 we have considered. So 0.8 lead, 0.6 lead, 0.4 lead, 0.2 lead, and ZPF 0 power factors okay, leading side. And approximated curve. So at unity power factor, this is the percentage R approximated here. So this type of the curve. So we got. So now in this case, okay, here maximum voltage regulation occurs. So maximum voltage regulation, it is almost equal to, so maximum voltage regulation so is equal to percentage impedance of the transformer. Already I have written here percentage. And at unity power factor, this value is equal to percentage R. So this is the 0 voltage regulation here. So from this diagram, so what is the conclusion? Another point, the 14th one. Per unity power factor load, so UPF load, voltage regulation, percentage voltage regulation is positive. Always positive here. Per unity power factor load, percentage voltage regulation is positive. And next one, so per lagging power factor loads. So voltage regulation, for any lagging power factor, voltage regulation is the positive only. So next one, per leading power factor loads. So then what will happen? So per leading power factor loads, voltage regulation. So this is the percentage voltage regulation is equal to. So per lagging power factor, percentage voltage regulation is the positive one. And per leading power factor, percentage voltage regulation is equal to positive voltage regulation or negative voltage regulation or 0 voltage regulation. So we cannot say. So this value is a positive, this is a 0, and this is negative. So per lagging power factor, voltage regulation of the transformer is always positive. Per leading power factor load, voltage regulation of the transformer may be positive negative or the 0. But unity power factor voltage regulation of the transformer, so maybe positive, so maybe always positive value only. సో క్వశ్చన్ ఎలా అడుగుతారంటే 0.8 పవర్ ఫ్యాక్టర్ దగ్గర కొంత వోల్టేజ్ రెగ్యులేషన్ ఇచ్చి 0.8 పవర్ ఫ్యాక్టర్ లీడింగ్ దగ్గర అడుగుతాడు. సపోజ్ ఇక్కడ 0.8 పవర్ ఫ్యాక్టర్ దగ్గర 98% ఉందనుకోండి, 0.8 పవర్ ఫ్యాక్టర్ దగ్గర లీడింగ్ దగ్గర ఎలా ఉంటుంది? సో ఇట్ ఈస్ ఆల్వేస్ లెస్ దాన్ 98% అని చెప్పొచ్చు. ఒకవేళ క్వశ్చన్లో 0.6 పవర్ ఫ్యాక్టర్ లాగింగ్ దగ్గర అనుకోండి, ఇట్ ఈస్ అ గ్రేటర్ దాన్ the 6%. So these are all possible questions from voltage regulation of the transformer, or so we can call it as short notes in voltage regulation of the transformer. So these are all possible questions from the voltage regulation of the transformers. You don't have more than this. So these summary points are required to answer any type of the question. Let us start the question number 1. So let us solve the question number 1, and question number 1 is a transformer has leakage impedance of ZE equal to RE plus JXE, and its voltage regulation occurs at a power factor of option 1 RE by XE leading, option number 2 RE by ZE leading, and option number 3 XE by ZE leading, and option number 4 RE by ZE leading. And RE is nothing but equivalent resistance, XE is a equivalent reactance, ZE is equivalent impedance. And condition to get zero voltage, condition to get maximum voltage regulation is equal to tan theta 2 is equal to percentage X divided by percentage R. So this also we can write X equivalent divided by R equivalent values. Okay, R equivalent. And from here we can get, so this percentage X by percentage R. And from this condition we can get triangle, and this is the theta 2, percentage X, opposite side, adjacent side is percentage R. Sum of these two will get percentage impedance. Now we required power factor. So power factor is nothing but the cos theta 2. Cos theta 2 is equal to percentage R divided by percentage impedance of the transformer. This is also equal to R equivalent divided by Z equivalent. The equivalent resistance divided by equivalent impedance. So R equivalent divided by Z equivalent. But this always maximum voltage regulation occurs at lagging power factors only. Lagging power factor. So answer for this question, option number 2. Maximum voltage regulation occurs at lagging power factor, and power factor at which maximum voltage regulation is equal to RE equivalent divided by Z equivalent. Next, let us solve question number 2. A transformer has leakage impedance of ZE equal to RE plus JXE. Zero voltage regulation of this transformer occurs at a power factor of option 1 RE by XE, option number leading RE by ZE leading, lagging, XE by ZE leading, RE by ZE leading value. So zero voltage regulation of transformer occurs at leading power factors. These are generalized conditions. The leading power factors. And what is the condition to get zero voltage regulation? From this condition is equal to tan theta 2 equal to percentage R divided by percentage X. So from this condition we can write the triangle. So this opposite side is percentage R, adjacent side is percentage X, and hypotenuse is percentage impedance of the transformer. So therefore power factor is equal to, so power factor is cos of theta 2. So cos theta 2. So it is equal to percentage X divided by percentage impedance, and this also we can write X equivalent divided by Z equivalent, but at what power factor? Leading power factors. Why? Because 0 voltage regulation occurs at leading power factor here. So X equivalent divided by Z equivalent leading. So option the 3 is correct for this question. And next possibility of the question, a 3-phase transformer has per unit impedance of 0.02 and plus J per 0.04. Its voltage regulation at a power factor 0.8 lagging and 0.8 leading respectively. These are options for this question. And at 0.8 power factor lagging, so this 0.8 power factor lagging, first one let us calculate at the 0.8 power factor lagging. What is the formula to find out percentage voltage regulation at lagging power factor? Percentage R cos theta 2 the plus percentage X sin theta 2. So this is the formula, generalized formula to find out percentage voltage regulation at lagging power factor. And this is a per unit resistance, so that percentage resistance value is equal to the 2% and percentage reactance is equal to 4% value. So therefore it is equal to 2 into 0.8 the plus 4 into 0.6. So 2 into 0. Means 1.6. So this is equal to 2.4. So by solving this we will get the 4%. So percentage voltage regulation at 0.8 power lagging is equal to the 4%. And next one at 0.8 power factor leading. Let us calculate the percentage voltage regulation at 0.8 power factor leading. At 0.8 power factor leading, see here percentage voltage regulation is equal to at leading power factor percentage R cos theta 2 minus percentage X sin theta 2. So this is the formula to find out percentage voltage regulation at leading power factor. And this value is equal to, so this 2 into 0.8 minus of 4 into so 0.6. If cos theta is equal to 0.8, then sin theta will become 0.6. And by solving it is a 1.6 minus, and it is a so minus 2.4. So now this value is equal to minus 0.8%, and it is a 4%. At lagging power factor is a 4%, at leading power factor is minus 0.8%. So option the 2 is correct for this question. ఏదైనా మనకి ఇచ్చిన అబ్జర్వేషన్ నుంచి సాల్వ్ చేయొచ్చు. నువ్వు ఆ కీ పాయింట్స్ పర్ఫెక్ట్గా గుర్తుంటే సో ఎలాంటి క్వశ్చన్ అయినా కూడా ఆన్సర్ చేయవచ్చు. అండ్ నెక్స్ట్ క్వశ్చన్ నెంబర్ 4 తీసుకుంటే 10 kVA 400 by 200 volt single phase transformer with a percentage resistance of 3% and percentage reactance of 6% is supplying a current of 50 amps to the resistive load. Now this is very important. The 50 amps to the resistive load. The value of the load voltage is option 1 194 volts, option 2 390 volts, and option 2 192 volts, and option 3 196 volts. And in this case voltage rating of the transformer is 400 upon the 200 volts. This is a voltage rating of transformer. And always the EMF rating mentioned on the nameplate details is primary induced EMF to the secondary induced EMF. So it is always EMF induced in the primary winding divided by EMF induced in the secondary winding of transformer. And unity resistive load means power factor is equal to per resistive load. So per R load, so load power factor, so this load power factor is equal to 1. So that is known as unity power factors. You can call it as unity power factor. So per unity power factor or percentage voltage regulation of the transformer, the at unity power factor so is equal to percentage resistance of the transformer. And this you can write E2 minus V2 divided by the V2 multiplied by 100. So V2 minus V2 divided by multiplied by 100, the is equal to percentage R. What is the voltage V2? So that is a 200. We have to find out V2 divided by E2. So into, sir, V2 is equal to 200 here. So this is the 200 multiplied by 100. So percentage resistance of the transformer is equal to 3%. So therefore this is equal to 3. So now simplify here, and it is equal to 200 minus, okay, this value is equal to 200 minus minus V2 is equal to the 6, and therefore V2 is equal to 200 minus 6, or V2 is equal to 194 volts. So answer for this question 194 volts is correct. And next let us solve the question number 5. The full load voltage regulation of power transformer is 0 when power factor of the load is near. Option 1 unity and leading, 0 and leading, 0 and lagging, and unity and lagging. So 0 voltage regulation of the transformers occurs at leading power factor, but which is very nearer to the unity power factors. So 0 voltage regulation of the transformer occurs at leading power factors, which is nearer to unity power factors. So answer is unity and leading. So this option 1 is correct. Let's solve the question number 6. The voltage regulation of the transformer at full load and 0.8 power factor lagging is 2.5%. Voltage regulation at full load 0.8 power factor leading will be option 1 minus 2.5%, option 2 0, option 1 minus 0.9%, and option 4 is 2.5%. So this question can be answered by using voltage regulation curve. So voltage regulation curve drawn between the percentage voltage regulation and power factor, and it is, I am considering it is a unity power factor. This is lagging power factor region, and this is a leading power factor region. So leading power factor region, and approximated curve. Suppose this voltage regulation is positive voltage regulation, and this is the negative voltage regulation, and approximated curve. So this is the exactly approximated curve of the voltage regulation of the transformer. And this, if it is a 1 here, 0.8, 0.6, 0.4, 0.2, and it is a 0. And also this one is a 0.8, 0.6, 0.4, 0.2, and it is a 0 power factor leading. So question is given that voltage regulation of the transformer at 0.8 power factor lagging, this is equal to 2.5%. But exactly at 0.8 power factor leading, what is the approximate answer here? So we cannot get 2.5%. So this option is not correct. So we cannot get the 0 also. So 0 is also not possible. So not good. And minus the 2.5% is also not possible. And approximated answer for this question is minus 0.9%. By using formula, we cannot answer. See here, why we cannot answer this question by using formula? Per lagging power factor, percentage voltage regulation is equal to percentage R cos theta 2 plus percentage X sin theta 2 1. So now here this is equal to 2.5. Here percentage R, the 0.8 plus percentage X, the 0.6. So this is the one equation. But here how many unknowns are there? There are 2 unknowns, so that we cannot answer this question. And next, suppose per leading power factor, what is the voltage? If you know percentage resistance and percentage reactance, so we can answer. But in this question, not mention the percentage resistance and current. We have to select the approximated answer. So what is the voltage regulation? We cannot say 0, but this was the approximate answer is minus the 0.9%. So this is not correct, this is also correct. So approximate answer is expected answer for this question is minus 0.9%. So this was the discussion of concept through question. అంటే క్వశ్చన్స్ నుంచి కాన్సెప్ట్ ఏ విధంగా నేర్చుకోవాలనేది సో ఈ వీడియోలో డిస్కస్ చేయడం జరిగింది. మరి సాయిమేధ కోటి హైదరాబాద్లో ద వీడియో కంటెంట్ అంటే ఆన్లైన్ కోర్స్ ఏ విధంగా ఉంది అనే విషయాల గురించి ఇప్పుడు మీ దగ్గర చర్చిస్తాను. మొదటగా టాపిక్ వైజ్ డిజిటల్ వీడియో క్లాసెస్ అనేవి ఉంటాయి. సో అంటే ప్రతి సబ్జెక్ట్లోని ప్రతి టాపిక్లో థియరిటికల్ క్లాసెస్ ఎలాంగ్ విత్ సమ్ ప్రాబ్లమ్స్ ఆ క్లాసెస్ ప్రొవైడ్ చేస్తాం. అండ్ అది వాటితో పాటుగా జెన్కో పీవైక్యూ క్వశ్చన్ను డిస్కస్ చేయడం జరిగింది. అండ్ నెక్స్ట్ ఇంజనీరింగ్ సర్వీస్ యొక్క పీవైక్యూస్ ప్రీవియస్ ఇయర్ క్వశ్చన్స్ డిస్కస్ చేయడం జరిగింది. జెన్కో ట్రాన్స్కో డిస్కంలో వచ్చినటువంటి ప్రీవియస్ ఇయర్ క్వశ్చన్స్ను కూడా డిస్కస్ చేయడం జరిగింది. వీటితో పాటు అదర్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్లో వచ్చినటువంటి పీవైక్యూ క్వశ్చన్స్ కూడా డిస్కస్ చేయడం జరిగింది. ఇప్పుడు ఎలాగైతే తెలంగాణ, ఏపీ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్స్ ఎగ్జామ్ ఉన్నాయో, సో ఇలా జెన్కో ట్రాన్స్కో ఏ విధంగా ఉంటుందో అదర్ స్టేట్లో ఉన్నటువంటి స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్ కూడా మనకు రిక్రూట్మెంట్ కండక్ట్ చేసే క్వశ్చన్స్ ఎగ్జామ్ క్వశ్చన్స్ కూడా డిస్కస్ చేయడం జరిగింది. సో వీటితో పాటు ప్రతి సబ్జెక్ట్లో స్టాండర్డ్ టెక్స్ట్ బుక్స్ యొక్క అబ్జెక్టివ్ క్వశ్చన్స్ కూడా డిస్కస్ చేయడం జరిగింది. సో ఈ విధంగా ఒక ప్లాన్గా ఒక స్ట్రక్చర్గా ప్రతి సబ్జెక్ట్కు వీడియో కంటెంట్ అనేది ప్రొవైడ్ చేశాం. మరి ఇలాంటి కంటెంట్ మీకు అతి తక్కువ ప్రైజ్లో అందిస్తున్న ఏకైక సంస్థ ఏదైనా ఇండియాలో ఉంది అంటే అది సాయిమేధ కోటి అని కోటి హైదరాబాద్ మాత్రమే. సో ఎంత ప్రైజ్లో అందిస్తుంది అనేది ఒకసారి మీ ముందు చెప్తాను. ఏఈఏడబ్ల్యూ కోర్సెస్ తీసుకున్నట్లయితే ఆన్లైన్లో ఓన్లీ ఆన్లైన్లో తీసుకుంటే అది 9,000 రూపీస్ వస్తుంది. తర్వాత ఆఫ్లైన్ ప్లస్ ఆన్లైన్ కోర్స్కి వెళ్ళినట్లయితే అది 27,000 రూపీస్లో మీకు యాక్సెస్ అనేది ఇవ్వబడుతుంది. మరి ఈ యాక్సెస్ ఏ విధంగా తీసుకోవాలి అంటే ఎక్కడ ఉంటుందంటే సో స్పేస్ గేట్ అంటే సాయిమేధ కోటి హైదరాబాద్ ఇన్స్టిట్యూట్ యొక్క మరొక యాప్ అయినటువంటి గేట్ మరియు ఏఈ ఒక జేఈ ఎగ్జామ్స్ కొరకు సపరేట్గా యాప్ అనేది ప్రొవైడ్ చేసాం. ఆ యాప్ పేరు ఏంటంటే స్పేస్ గేట్ యాప్. సో ఈ యాప్ డౌన్లోడ్ చేసుకున్న తర్వాత మీకు ఇంకా ఎలాంటి డౌట్స్ ఉన్నా సో సబ్జెక్ట్ పాయింట్ ఆఫ్ వ్యూలో కావచ్చు, తర్వాత ప్రైజ్ ఇంకా ఏమైనా డిస్కషన్ చేయాలన్నా, తర్వాత సో ఇంకా ఏ విధంగా డౌన్లోడ్ చేసుకోవాలనుకున్నా కూడా సో ఇక్కడ కనిపిస్తున్న నెంబర్కు కాల్ చేయండి. నెంబర్ మరొకసారి మీకు చెప్తాను, 9848692598 9849713451. సో ఈ 9849713451 అనేది సాయిమేధ కోటి హైదరాబాద్ మా ఇన్స్టిట్యూట్ యొక్క సాయిమేధ కోటి హైదరాబాద్ కోఆర్డినేటర్ శశికాంత్ వాల్మీకి సార్ గారు. మీకు ఎలాంటి డౌట్ ఉన్నా ఈ నెంబర్కి కాల్ చేయండి, సార్ మీకు వివరంగా ఎక్స్ప్లెయిన్ చేస్తాడు. సో కోర్సును ఏ విధంగా తీసుకోవాలి, తర్వాత ఏ విధంగా ప్రిపేర్ అవ్వాలనేది కూడా సార్ మీకు చెప్తాడు. సో కోర్స్ తీసుకున్న తర్వాత సో ఇలాంటి ఆన్లైన్ కంటెంట్ మాత్రం వేరే దగ్గర మీకు ఎక్కడ కూడా దొరకదు. అంటే ఓన్లీ థియరిటికల్ క్లాసెస్ ఉంటాయి, ప్రతి టాపిక్ 2-3 క్వశ్చన్స్ అనేవి ప్రొవైడ్ చేస్తాం. సో అలా కాకుండా ఒక స్ట్రక్చర్గా ఒక 3-4 ఇయర్స్ బ్యాకే అంటే స్టూడెంట్స్కి ఏది అవసరమో ఆ విధంగా కోర్సును డిజైన్ చేయాలని ఒక ఫోర్కాస్టింగ్తో చేసిన అటువంటి ఈ కోర్స్ ఇది. సో మీ ప్రిపరేషన్కు ఏడబ్ల్యూ ఎగ్జామ్ ఆంధ్రప్రదేశ్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్లో ఏడబ్ల్యూ ఎగ్జామ్కు మీరు ఏ విధంగా ప్రిపేర్ అవ్వాలి, తర్వాత టాప్లో మీరు జాబ్ కొట్టాలి అనుకుంటే మాత్రం వాళ్ళ ఆన్లైన్ కోర్స్ తీసుకోవాలనుకుంటే ఈ కోర్స్ అనేది మీకు తప్పకుండా యూజ్ అవుతుంది. సో యాజ్ ఏ ఫ్యాకల్టీగా నేను అనాలిసిస్ చేశాను కాబట్టి ఇంత ఖచ్చితంగా మీకు చెప్పగలుగుతున్నాను. సో ఐ హోప్ యూ గాట్ ఇట్. ఐ విష్ యూ ఆల్ ద బెస్ట్. థ్యాంక్ యూ వెరీ మచ్.